Hello everybody, this is Cameron Snow with Danomics.com. In this video, I'm going to review some of the new capabilities in Danomics related to the laminated sand and shell analysis. Let's get started. So when you're doing this analysis, the first thing that you'll want to do is you'll want to do your petrophysical interpretation per usual through, in my opinion, cutoffs on your key well. So you would still come in and do your curve normalization, your bad hole repair. You would do your interpretations on clay volume, TOC analysis, porosity, saturation, and cutoffs as usual. And then you would determine if there are zones where you need to apply the laminated sand analysis. Now, in order to do this, what you would need to do is you would need to go to your porosity interpretation module, and you'll notice there's a new parameter there called laminated shell analysis. And in this case, we're going to apply it to two formations, the Sussex and the Shannon, and we are going to activate it for those two zones. Now, you'll notice when I do that, all of a sudden it really creates like quite a jump, an unrealistic jump in my porosity here, and that's because I have not yet set any of the interpretation parameters that are relevant to the laminated sand analysis. So let's go do that. So what we need to do is come here to our central drop-down menu, and we need to come down and select laminated sand analysis. And when we come here, what we see is that we have a number of tracks that are available to us that have different parts of the interpretation. We're going to go through each of the three parts, and I like to think of this in three sections. The first is focused on calculating our V shell. The second is looking at the effects of that on our porosity and our saturation calculations. And the third is doing some quality control work on this. So we specifically have two tracks here that are set up to help you find problems in your interpretation. Okay, so let's start off with V-shell. As you probably know, when you're doing this laminated sand-shell analysis, we need to look at V-shell, not at V-clay. That's how this work was initially done by Thomas-Stieber. So what options do we have here? Well, there are three methods that are available to us. There's what we call a ratio method, a gamma ray method, and a neutron density method. So what are those? The ratio method is the V shell that we calculate out of the clay volume module, and it is simply a ratio of shell to clay. So if we come here to our clay volume module, we see that we have this clay to shell ratio parameter. Right now it's set at 0.7. And what we see is that then performs the calculation and tells us that, hey, in this interval, our V shell is around, let's say 55%, and our V clay is at around 40%. So we have that. That is the ratio method. We also have a gamma ray method and a neutron density method. So the gamma ray method, this is one where we need to identify the gamma ray of a clean sand, the gamma ray of a very shaly interval, and then we set those two parameters and we calculate a V shell based on those. Now I've already done some of this work, and I'm going to just generically set the values here at 40 and 150 for our sand and shell values. As we do that, we see that the results automatically update here, and we see that our V shell of gamma ray curve is now very, very similar to our V shell from the ratio method in our two zones of interest. We have a third method that's available. That's the V shell from neutron and density. Here in the neutron and density plot, you will see that we have two parameter lines that can be adjusted zone by zone. I am just going to set some defaults here, and I'm going to set 2.63 for my row B of shell, and that's just based on about visually where I see the maximum value here, and I'm going to use about 0.36, which once again is just based on a quick visual analysis of my results. And once again, you'll see that this brings our V-shell from neutron density kind of in line with our V-shell from the ratio method. Depending on the zone, it may be higher or lower than the gamma ray method. Now, once we have selected the method that we want to use, in this case, I'm going to use the gamma ray method, the next step is to move on to our Thomas-Stieber cross plots here. And if you're not familiar with this cross plot, it's a cross plot of total porosity on the y-axis versus shell volume on the x-axis. And the two parameters that we need to set are the total porosity of our sand and the total porosity of our shell. Oftentimes you will see a trend develop in this data, and what you're going to want to do is fit this line to that trend. Now you may be wondering, how can I, dial in these values? On the sand side, if you have got some core data and you've got core data from some of those clean sands, maybe this is where you want to take that core data and use that to say, hey, I know where I have clean sand. My core data is maybe, 17%. So you can put that number in, and then you look at where does my shell volume have to be to to get that to fit the trend line. That needs to be at, I don't know, let's say 5.5%. So I'm going to put that at 0.055. Now I see I've got a pretty good fit to that trend going through there. As I do that, that's going to update my calculated volumes of dispersed clay, structural clay, and laminated clay. And that in turn will update my new total and effective porosities. And we can see how this new calculation compares to our original total porosity for this zone. And we can see that it is, in most cases, quite a bit higher. We have also updated our saturations as part of this, so that new porosity is now flowed into the saturation, as well as our our new sand resistivity. Okay, so we've got that updated. Now, one thing to note here is we've got that done. We do need to set our resistivity of our shell, and we do that by either, once again, dragging or dropping this line or typing into the box. In this case, the default of about 4 ohms is roughly correct. It's pretty good starting estimate here. And now we get to the QC part of our interpretation. So here we have 2 tracks. The first track is focused on QCing our corrected neutron density. In general, here we don't want to see the neutron curve less than a density porosity curve in this zone. And in general, for our resistivity of sand, we want this to be greater than 0. So let's look at how this QC works. So let's say here we're using our V shell from gamma ray. Let's say I had set a bad V shell value here. Let's say I had set this at 20 for our gamma ray shell, and let's say I had set this maybe way too high. Set that up at 180. What you'll notice is as we let me actually put that lower here. Let's put that at 120. So set this too low. You'll see that we get a bunch of red shading in here, and that shading is telling us that what we've done mathematically is not feasible. And so what we need to do is we need to adjust this value until that shading disappears. You can see it's largely gone here, but we still have a little bit. And so now we're going to clean up the bottom half of that distribution, and voila, now we see that we have got rid of that shading and we have a mathematically potential answer. So that's that part of the QC. Second part of the QC is focused on the resistivity of our sand. Obviously, resistivity has to be a positive number. However, we can get in a situation Mathematically, where the resistivity of sand we're calculating is incorrect. This most often happens when we have the wrong shale resistivity. And let's say for some reason, maybe I had looked at my zones here, and I had set this closer to my minimum resistivity that I observe in this well. Well, if I do that, I set this too low. What I see is, once again, this red shading appears, and that tells me, hey, it's too low. And so you want to come in and adjust that on a zone by zone basis until you see that red shading go away, and that tells you that you are in a mathematically uh, feasible solution. It's not saying that your answer is correct, it's just saying that you have got out of that definitely incorrect space. Now, once you have done this, these results will have been passed uh, into your porosity and saturation. So let's just jump back and take a look at that real quick. So here, once again, we see that we have our laminated sand analysis on for these two zones, and we can see that our total and effective porosity here is quite a bit higher. Let's turn that off. Once again, this is what it looked like beforehand, and this is what it looks like afterwards. So there is our after result. Now, note that this is estimating the porosity of the sand. That means when we get here to our cutoffs and our volumetrics, before we summarize those and map those up, we need to apply a net to gross. Danomics does this for you behind the scenes. So when you calculate a net pay summary or a net reservoir summary, that is already going to be applied. And when you come in here to your volumetrics analysis and you're calculating whether it's an oil in place or a hydrocarbon pore volume, we have already applied the appropriate net to gross based on the laminar shale volume of those rocks. All right, well, I hope this has been interesting to you. Once again, you'll do your interpretation as usual. You will then activate the laminated sand-shale analysis, where you will use the central drop-down menu to take you to that module. You will then apply those calculations, tune the parameters, and then those results will be injected back into the porosity and saturation and will flow all the way through your cutoffs and volumetrics automatically. All right, if you have any questions about this process, please reach out to us at support@danomics.com. Thank you.